Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, let's see the another sum of cantilever beam with UDL. Let's see in details. Now this is a question given to you. A cantilever of 2 meter long carries a UDL of 10 kilonewton per meter over 1 meter portion from fixed end, a point load of 20 kilonewton at free end. Calculate the maximum slope and deflection of a cantilever. Take EI is equal to 2 into 10 raised to 7 kilonewton mm square. Now in that problem we don't have given the diagram, so first draw the diagram. Start with the solution. Now start the solution and draw the diagram first. Now see, this is a diagram we have drawn. A cantilever beam of 2 meter long, cantilever beam 2 meter long, so that carries a UDL of 10 kilonewton per meter over 1 meter portion from fixed end. Carrying a UDL of 10 kilonewton per meter in 1 meter from the fixed end. So this is 1 kilonewton and we have given a point load of 20 kilonewton at the free end. After that, calculate the maximum slope and deflection of the cantilever. Take EI is equal to 2 into 10 raised to 7 kilonewton mm square. So let's start. What is our first step will be, as Macaulay says for us, if we have a UDL part, so always take the section in the UDL. So take the section in the UDL first. So you are taking section over here like this, and your this distance is nothing but x. This distance is nothing but x, and this is your origin. As you all know, we neglect the fixed part in overhang in cantilever beam, as you all know. So we have not done in that, we don't have to find the reaction first. So after that, what we are doing, after that we are just taking section dot line and draw the x values over here. So as this is origin, always take origin x is equal to 0. So extend this part over somewhere else, like, and write it over here, x is equal to 0. Okay, after that take a section over here and take one box and write over here x is equal to 1, and this one is over here. Okay, now after that, what is our next step? Our next step will be using double integration method. We have to take the section over here, bending moment at this distance, and find the Macaulay's method over here. So using double integration method, as you all know, another name of double integration method is nothing but Macaulay's method. So we have to find over here bending moment at x is equal to, means this is your x, bending moment at x is equal to EI d square y upon dx square. Okay, dx square upon dx square. After that, see, is equal to, what's the value come over here? See, we have taken section over here and see this part. See, this is hogging, so that's why it's come minus 20 into x. 20 into this distance will be x. After that, this UDL come in the picture, so this is also in the hogging direction. So minus 10 into x minus 1 into x minus 1 divided by 2. Okay, now this done with this part, so cut it over here. See, this one, this is 5, so rearranged it one time. Minus 20x minus 5x minus 1 the whole square. Okay, now we have done with this part. After that, what we are doing, we have to integrate this part. integrating this part. So integrating, now while integrating we get over here EI dy by dx is equal to, now see, this is 20x. What is the integration of 20x? Will be minus 20x square by 2. After that, this minus 5 into x minus 1 raised to 3 upon 3 plus c1, equation number 1. After that, while now find the c1 value. As you all know, in cantilever we are finding the different. So now applying first boundary condition to find c1. Okay, applying first boundary condition to find c1 over here. So after that, put x is, as you all knows, apply the boundary condition. In fixed there is only a one boundary condition, at x is equal to 2, dy by dx is equal to 0. As you all know, in cantilever part there also no have a slope over cantilever part. Put in equation 1. So equation 1 is just 0 is equal to minus 20 into 2 square by 2 minus 5 into 2 minus 1 the whole raised to 3 upon 3 plus c1. Okay, now 0 is equal to minus 40 minus 1.67 plus c1. While solving this, you get the value of c1, 41.67. After that, now we get the value of c1. Now put in equation number 1. Now this c1 value put in equation number 1. So what's the value come over here? EI dy by dx is equal to minus 20x square by 2 minus 5x minus 1 raised to 3 upon 3 plus c plus 41.67. This is nothing but A is nothing but your journal slope equation. Okay, A is nothing but your journal slope equation. After that, integrating again. After that, integrating again. So what's the come over here? EI y is equal to minus 20x raised to 3 upon 6 minus 5 into x minus 1 raised to 4 upon 12 plus 41.67x plus c2. This is nothing but equation number 2 over here. Now apply second boundary condition to find c2. Now applying the second boundary condition to find c2. So at x is equal to 2, y is equal to 0 over here. Put in equation number 2. Put in equation number 2. So what's the value come over here? See, this is 0 equal to, after that this minus 20 into x raised to 3 upon 6. We are putting x is equal to 2. Now see, put in equation number 2. What is equation number 2 over here? Minus 20 into 2 raised to 3 upon 6 minus 5 into 2 minus 1 raised to 4 upon 12 plus 41.67 into 2 plus c2. Now solve this. While solving this, you get the value of c2 will be minus 56.25. This is your c2 value. Now this value put in equation 2, put in equation number 2. So we get the value over here ei y is equal to minus 20 x raised to 3 upon 6 minus 5 into x minus 4 raised to 4 upon 12 plus 41.67 x minus 56.25. This is nothing your B equation, and B is nothing but your journal deflection equation. Okay, after that in exam we have find in question given over here, we have to find the maximum slope and deflection in cantilever beam. So write one note over here. To find maximum slope, this is Q max, and maximum deflection, this is nothing but Y max. Maximum slope and deflection will occur at B. As you all know, in cantilever beam, maximum slope and deflection occurs at the free end, which is nothing but B part, at B part, as you all know. So write one note over here. Now to find QB and QB and YB. Now we have to find, first one is find theta B. QB is nothing but, Q is nothing but theta. By mistake it will get Q. So it will theta B. So in theta B, put x is equal to 0 in equation journal slope equation. Okay, now see what will come over here. See, which is your journal. Now see, this is journal slope equation for you. Now put the x is equal to 0 in this equation. Okay, so it will get over here ei dy by dx is equal to minus 20 0 square upon 2 minus 5 0 minus 1 raised to 3 upon 3 plus 41.67. Okay, so ei theta b will be, as you all know, Macaulays don't read 0 or minus, so directly it will get 0 over here. Now 0 minus 0 plus 41.67. So QB will be 41.67 upon EI. But in exam you have given the value of EI. So EI value you have given 2 into 10 raised to 7 kilonewton mm square. Now you have to convert this value into kilonewton meter square. So how will you convert? 2 into 10 raised to 7 into 10 raised to minus 3 the whole square meter square. Okay, so it will come 2 into 10 is equal to 20 kilonewton meter square. Now put this value over here, 41.67 upon 20. Therefore QB will be 2.08 radian over here. Okay, now 2.08 radian. After that, now to find QB and after, sorry, theta B, after that we have done with the slope. After that, find the deflection. Now next part will be to find YB is nothing but deflection at B. Now in deflection at B, what we are doing, just see the diagram. Now this is the diagram. While finding at B, put the x is equal to 0 in journal slope equation, sorry, journal deflection equation. So put x is equal to 0 in journal slope equation. Okay, sorry, we have to put journal deflection equation, not slope equation over here. So done but by mistakes. So please listen first. Now see, this is a journal deflection equation. Put the x is equal to 0 in this value, this equation. Okay, this is equation number B. So write it over here. EI y is equal to minus 20 0 upon 6 minus 5 minus 56.25. Okay, now as you all know, mechanics don't read the 0 and minus value, it will directly get 0, both 3. Now you get EI YB is equal to minus 56.25. so YB will be minus 56.25 upon EI. As you all know, the value of EI will be 20. 56.25 upon 20. Okay, 20. So you get the value of YB will be minus 2.8125 meter. Then YB will be minus 281.55 mm. Okay, now we have done with this is your final answer. Now we have find the general slope equation also and general deflection equation also. After that, see the question. After that, see the question. We have done with part maximum slope occurs at the free end, maximum deflection occurs at the free end, as you all know, in cantilever beam. I hope you understand my video, and don't forget to subscribe and please share with your friends. Thank you so much.